In this video, we'll be looking into minimization of DFA by using table filling algorithm. So the problem statement says that consider following DFA and minimize this DFA using the table filling algorithm. So here, this is the start state and C being one of the final states, F and I. So this is the problem statement given. So here I've written down the steps which need to be followed for the minimization procedure. Here we need to note that as the transition table comprises of more than one final states, we should not mark CF, FI or CI combinations. So we should, as it has CI and F are the final states, we should not consider their combinations, that is CI or IF or CF. So these should not be marked in the table. So our first step is to draw the transition diagram for the given DFA. So let's draw the transition diagram. This is A, we have B, C, D, E, F, G, H and I here. So on A on A gives B, A on B gives E, B on A gives C, B on B gives F, C on A gives D, C on B gives H, D on A gives E, and D on B gives H, E on A gives F, E on B gives I, so I is here, and we have F on A gives G, and F on B gives B. So, and G on A gives H, and G on B gives B. Then we have H on A gives I, so I is here, H on A gives I, and H on B gives C. Then we have I on A gives A, and I on B gives E. So we have drawn the transition diagram. So here if we see, all the states are being connected directly or indirectly from the start state, that is A. So A is directly or indirectly connected with all the states. Thus we can say in the step 2 that all the states are reachable from start state, so no states should be eliminated. So our next step is to construct the table. So here let's write down all the possible combinations starting from AB. A is not possible, right? So AB, AC, AD, AE, AF, AG, AH and AI. Similarly, BB is not possible, so BC, BD, BE, BF, BG, BH and BI. CC is not possible, so CD, CE, CF, CG, CH and CI. Then we have DD is not possible, so DE, DF, DG, DH and DI. Then we have EF, EG, EH and EI. Then we have FG, FH and F comma I. Then we have GH and GI here, followed by that we have H comma I. So our next step is to select the states having final states, that is either C or I or F in it, and put a cross mark in the table. So this is what the table filling algorithm says. So now let's construct a table here. Now that I've constructed the table, let's mark whichever states are having C, I or F in it. So first AC, so AC or CA both are same. Then we have AC is done. Then we have AF, so AF needs to be marked. Then we have AF is marked. Then we have AI should be marked. But very important thing before that is CI, IF and CF should not be marked. So make sure that you put CI a small dot in CI, so that you shouldn't mark that. IF, put a dot there, and then CF, put a dot here. So make sure that you don't mark in these places. So let's move on to BC. BC can be marked. So BC can be marked. Then we have BI, which could be marked. BI could be marked. Then we have CD. CD could be marked. CD could be marked. CE could be marked. CF should not be marked. Then we have CG, which can be marked. CH and CI should not be marked. Then we have DE, DF. DF can be marked. DF can be marked. Then we have DGs, it can't be marked. Then DI can be marked, right? Then we have EF, which can be marked. Then we have EG, no. EH, no. EI, yes. EI, yes. Then we have FG, it can be marked. FH can be marked. FI should not be marked. Here we have GH and GI, GI can be marked. Then we have HI, HI again, it contains I, so yes, it can be marked. So we are done with the step 3. Now let's move on to step 4, that is to write down whichever states are not being marked here. Let's write down in a tabular format with on A, on B, A and B. So let's write it down. Now that I've written all the remaining entries, let's compute this. The transition of AB on A. So AB on A gives BC. So similarly, let's write down for all AB on B. AB on B gives EF. Here, as the first state is A, so it has to be common. The other section of this entry is varying, right? So similarly here also, so A on B gives E. So let's write down E here first, followed by the other side. So D on A gives E. Then we have F here. Then we have H here. Then we have I here. Similarly here we have H, I, B, and H on B gives C. Similarly, we'll fill the other entries also. Now here we have to check that, see, in AB it has BC and EF. So we have to check if any of these combinations have the final states in it, or if any of these are being marked here previously in the step 3. So BC and EF, check if BC is marked. Yes, BC is marked. Either BC should be marked or EF should be marked. Any one of this should comprise of the final state. If the situation holds true, then put a tick mark here and then mark it down in the table with a different color, representing that these states have been obtained in the next step. So AB can be marked. Yes, AB can be marked. Then we have AD. So is BE marked? No. Neither BE is marked nor EH is marked. So let's put a circle here. Then we have AE. So BF and EI, yes, we have. So AE can be marked. Then we have AG. So BH and EB, no. Then we have AH. Yes, BI is there. BI is there. So AH, let's mark it. Next we have BD. So CE is there. CE is marked. So let's put a tick here, the BD, and mark it down here. Then we have BE. CF, FI, no. As it has IF, or FI, so put a circle there. Then we have BG. So CH and FB, yes, it is available there. Then we have BH, it has CIFC, no. These shouldn't be marked, right? So put a circle there. Then DE, DE comprises of EF and HI. Yes, HI is marked, so put a tick there. And DE, ED, put a cross mark there. Then we have DG, DG has EH and HB, no, they are not there. Then we have DH, yes, put a tick mark there and mark DH here. Then we have EG. So EG has FH and IB, yes, they are marked here, so put a cross mark at EG. Then we have EH, so EH has FI, FI or IF, put a circle. Then we have GH, GH has HI, so HI is marked, right, so put a tick mark at GH and mark it down here. So in our next step, we should write down all the entries which are being circled here. So let's write it down here, step 5. So we have AD, AG, and BE, BH, we have DG, EH, and we have CF, and CI, and FI. These were not supposed to be considered, right? So let's write it down at the end, okay? So let's consider for AB. Let's write down the same values here. So BE and EH here. Then we have BH and EB here. Then we have CF and CI. Here FI and FC. Then we have for DG we have EH and HB. Then for EH we have FI and IC. For CF we have DG and HB. And for CI we have DA and HE. And here we have GA and BE. So out of these AB values, let's check if any of them are marked in the previous step. If yes, then put a tick and then circle, put a cross mark in the table. If not, put a circle there. So if you can see, none of these values are being marked in the table. So what do? This is the final step. Further, we cannot simplify or minimize the table further. So what do we do now? Now we can club the values together. So AD and AG can be clubbed together as ADG. A, D, G. Then we have BE and BH can be clubbed together as BEH. Here we have DGEH. DGEH, you can't club it, so let's write it as it is. So DG is clubbed here already, right? And EH is also clubbed here, so let's not consider these. Then we have CF and FI, so it can be written as CFI, right? And FI is already considered here. So we have got minimized transition table now. This is minimum DFA obtained. Here we have A and B. Now let's see, here we have BE and BH for A. So it can be written as BEH, right? So BEH. Similarly, here we can write it as BEH. Here it is CFI, combining these two. And combining these two, we get CFI itself. Then here we have CFI. Combining these two, we get DAG. And here we have BEH. So this is the minimum transition, the minimization of DFA. At max we can minimize the given DFA to this level. Now further, let's draw the transition diagram. That is the next step, right? So step 6 is to draw the transition diagram. So transition diagram A. So here A is the start state, right? So let's put an arrow here, and wherever there's CFI, let's put a star there. So star here. So A being the start state, yes. Then we have B and C. So let's now, before this, what we can do is we can rename these entities. So ADG could be renamed as A, and BEH can be renamed as B, and CFI can be renamed as C. So here it will be A on A will be B, and A on B will be B. B on A will be C, and B on B will be C. C on A will be DAG, that is ADG, A, and C on B will be BH, that is BH, B here. So we are drawing the transition diagram for renamed values. So A being the start state and C being the final state. So A on A gives B, A on B also gives B. So A comma B. B on A gives C, B on B also gives C. So here also A comma B. C on A gives A, and C on B gives B. So here we have obtained the transition diagram. Now let's quickly write or quickly define the M value, that is M of minimum DFA. This is our step 7, is equal to Q sigma transition function Q naught and F, where Q stands for all the states being considered. So this is Q value. Sigma, it comprises of only 2 alphabets, that is A and B. Then we have transition function is defined in all these steps here. Then we have the start state to be A, and we have final state to be CFI, CIF. So I hope you have understood how to solve this question. If you have any doubts, do let me know in the comments, and subscribe to my channel. Thank you.